Good morning, student. Today we are going to discuss about engineering mechanics. Okay, engineering mechanics. What is engineering mechanics? Engineering mechanics is the oldest physical science. Okay, it is the oldest physical science. Oldest physical science. It is the oldest physical science. And what is the definition of engineering mechanics? Okay, engineering mechanics is the branch of physics. It is the branch of physics which deals with the study of force and its effects on body. Basically, engineering mechanics it deal with the force, and whenever we apply a force on a body, whatever happen to the body is considered by the subject mechanics, engineering mechanics. Okay, engineering mechanics. Okay, that's engineering mechanics. In this subject, we are going to deal with the different type of forces and its effects. Okay, then what is effects? Basically, two types of effects are present. Okay, one is external effect and another one is internal effect. One is external effect and one is internal effect. Okay, basically engineering mechanics deal with the force and so was the external and internal effect, and which is used to design a mechanical component. Okay, so basically engineering mechanics is divided into two vast parts. Okay, two parts. What is that? I'll tell you. Engineering mechanics is divided into two parts. Okay, one is mechanics of solid. One is mechanics of solid. One is mechanics of solid, and the another one is mechanics of fluid. Okay, one is mechanics of solid and another one is mechanics of fluid. Okay, mechanics of solid is further divided into two parts. One is mechanics of rigid body and another one is mechanics of deformable body. So, mechanics of solid. This subject is we are going to deal with the subject MOS, mechanics of solid, which is in your second year subject. Okay, it is in your third semester, I think. Okay, MOS. And the mechanics of rigid body, it is the engineering mechanics. We are going to deal with this. mechanics of rigid body. The entire syllabus is based on this subject, this mechanics of rigid body. This is mechanics of fluid. This is fluid mechanics. FM, HM, there is a subject FM, which is in your fourth sem, I think. Okay. Then mechanics of deformable body. It is we are going to deal with strength of material. This particular subject we are going to deal with strength of material. Okay. How engineering mechanics is helpful for us? Okay. Whenever we are considering a body, let us assume we are taking a truss. Okay, this is a truss method. Okay, and I am going to explain how rigid body is helpful for us. Okay, this is the truss member. We are going to apply force here. This is some angle, just theta 1. This is some angle, theta 2. This distance is some 2 meters. This is 2 meters. This is some distance. This is some distance. This is some distance. After applying force, okay. After applying some force, the angle gonna change. Okay. Basically this angle would change. This something as 1x. Okay, change. What? Then the calculation will be tough. Okay. I am giving you another example. Easy example. Okay. Maybe you have studied in your 12th or anything else. So this is a cantilever beam. Okay. This is a cantilever beam. You might have studied it in your 12th. Okay. And there is a force F, and this distance is 2 meters. So you have to calculate this is A, this is B. Okay, calculate the moment at B. Calculate the moment at what will happen? And it's MB is equal to what is the formula for moment? Force into perpendicular distance. Perpendicular distance is 2 meters. So F, let us this force is 10 kilonewton. So 10 into 2 kilonewton meter. Okay, that implies that moment at B is equal to 20 kilonewton meter. Okay. What will happen? Actually, this is not gonna happen. Okay. When we apply force, this beam is slightly bending. Okay. Slightly bending like this, and the distance will change. The distance will change. Maybe it's 2.0001 or 1.999. Whatever small changes there will be happen. Okay. So what will happen here? So my calculation will be tough. So we are not going to consider small changes. So we consider this beam as a rigid body to make our calculation easier. Okay. Then mechanics is also divided into two parts. Okay, mechanics is so divided into two parts. One is static and another one is dynamic. Okay, mechanics divided into two parts. One is static and another one is dynamic. Static and another one is dynamic. Okay, one is static and another one is dynamic. What is static? Study about bodies at rest. Study of bodies at rest. Bodies at rest. Now what is dynamic? Bodies at study of bodies at rest. At motion. Okay, study of body at motion. So then dynamic is also divided into two parts. One is what? Kinematics, and another one is kinetics. One is kinematics and another one is kinetics. What is kinetics and what is kinetics and what is kinematics? Okay. Study of body without considering the force is called kinetics. Without considering the force. Study of body without considering the force. I am giving you an example. If I am going to kick a ball, how much distance will we travel it? Or suppose I have a tennis ball and I am going to drop it from here. Okay. Then how much the ball will be bounce. Okay. That we can calculate this. There is no need of force. Just you have to calculate the certain distance. What is the gravitational force? That will be enough for the ball to how much bounce. Okay. So we are not going to consider force there. So that is an example of kinematics. We are going to calculate that type of thing in kinematics. In kinetics, we are going to consider force here. We are going to consider force here. Okay. We are going to consider force here. Then most important topic, what is force? Everything is mechanics. Mechanics is a branch of science which deals with the study about force. Okay, force and its effects on body. Okay, so what is force? Force, it is the interaction between two bodies. It is the interaction two bodies. It is a bookish definition. Okay, it is a bookish definition. The interaction between two bodies. The force is the action of one body on another body that try to change the motion of other body. Okay. Force is the action of one body on another body which tries to change the motion of the body. Okay, motion of the other body. Let us consider. Okay, let us consider. This is a body. My hand is a body, and this is another body. I have put this body on my hand. So what will happen? This body supposed to push my hand to downwards, but I have that much of strength, so nothing will be happen. But this body is trying to put me down. Okay, this duster is applying some force on my hand to try the position, try to change the position. That is the work of force. Okay, let us consider this is a body. I am going to I have give a force P. What will happen? This body will move this direction. Okay, this direction. Let us consider this body moves from this position to this position. Okay. Now the position has changed, so the force has applied. I am giving another example. Okay. If you are sitting in a room, there is a roof and there is a beam. Let us consider there is a roof and there is a beam. On the beam there is a roof. Okay. So let us draw a free body diagram of that. Okay, free body diagram. We are going to draw a free body diagram. Suppose this is a body, this is your roof, and it lies on your beam. Okay. So what is the free body diagram? This is the free body diagram of this roof. Okay, and this is the free body diagram of your beam. Okay, in this case the roof will apply force like this to the beam, and the beam will react, or the beam will apply reactant force like this. Okay. Okay. This reaction and this action is called as force. And basically force is a vector quantity. Basically force is a vector quantity. Why it is a vector quantity? because it has some magnitude, it has some direction, and it has a point of application. Okay, it has some magnitude, it has some direction, and it has some point of application. Okay, how I am giving you an example. Okay, let us consider this is a body, and I am applying a force here. Okay. This is, the force is 10 Newton. Okay, the unit of force is Newton. Okay, Newton, 10 Newton force I have applied. This is what is this? This is the point of application. At which point the force is applied, that is called the point of application. Okay, this is the point of application. What is this? This is the magnitude. And in this direction, the force is going to travel. So this is the, what is this? This is the line of action. Line of action or direction. Okay, this is the line of action or direction. These are the 3 points where force is a vector quantity, because it has some magnitude, it has some direction, okay, and it has a point of application. Okay, then there is a most important concept called principle of transmissibility. Okay, principle of transmissibility. What is that? Principle of transmissibility. What is that transmissibility? Okay, that is principle of transmissibility.